In this video, I'm going to talk about the Hoplite shield, the well-known Argive shield, and there is a wealth of information out there about its general use in a formation and in battle, but I'm going to focus on some of the less well-known facts concerning its construction, its design, and its functionality. This shield was made by Dimitris Alexandrou from Chalkis, Evia, Greece. Dimitris has not been doing this commercially, but he has had hands-on experience through his collaboration with prominent archaeologists and museums. So this specimen is arguably one of the closest reconstructions to the originals, especially in regards to its metal fittings, its overall design, and its shape. The name Argive shield comes from the city of Argos, where the sources tell us that the shield type originated from. However, archaeologists can recognize the specific metalworking techniques and decoration techniques as Corinthian. Corinth is neighboring to Argos, and in the 7th century BC was perhaps the richest Greek city-state. This suggests one of a number of possibilities. Either there were Corinthian craftsmen working in Argive shield factories, or the fittings themselves were constructed in Corinth and exported to Argos, or the Argive craftsmen were copying the style of Corinth. There is also the possibility that despite the sources telling us that the shields came from Argos specifically, the earlier examples that we find actually come from Corinth. Although this reconstruction deserves a video on its own with a detailed walkthrough, for example, the exquisitely made rim, one-piece bronze rim with a hand-hammered guilloche pattern, or the bronze emblem. This one is based off one from Olympia. Today I want to focus mostly on the Porpax construction and the placement of the internal fittings of the shield, which greatly affect its usability. Through archaeology, we can detect a number of different Porpax construction techniques. Perhaps the most well-known is the solid bronze Porpax that was meant to be lined with a thin lining like felt or leather, or a combination. There were definitely a type or subtype where a wooden core was covered by a very thin bronze cover, and we know this because there are examples that still retain quite deep rivets or nails, and remnants of the wood remain around these nails. And then there is the slightly later but quite common through the classical period type, which was a wooden base with only a very thin metal band connecting it to the core, and we can imagine how this wooden core would have been covered in leather and decorated with other materials like ivory or bone, remnants of which we can find in some ancient specimens. Another subtype that could be used with any of the aforementioned examples was the removable Porpax. Hinges were used on the top and bottom, and by inserting a pin you could attach or detach the Porpax. And few, but a number of such examples have been found throughout Greece and dating to probably a large span of time. Like with everything else, we find good Porpaces and bad Porpaces in the archaeological record. Like we find good sword blade material or bad sword blade material. Or we find exquisitely made and shaped greaves, but we also find less well-shaped greaves. Here we're going to talk about a good, well-shaped Porpax. In fact, the majority of the ancient finds are well-shaped, and we're not going to talk about the exceptions. The difficulty in constructing a well-shaped Porpax is that throughout its surface it has an anticlastic shape. That is, it is bent both around the arm, but in all its surface it's bent also in the other axis, which is quite difficult to make. However, there is very good reason or reasons why this was the case. First of all, this gives it such a rigidity that although the thickness of the metal is quite thin, it is very stiff, it becomes very stiff, and it's almost impossible to bend with pressure. In some of our experiments at Marathon, where we replicated Othismos, we saw that some of the Porpaces, they not so well made reenactors Porpaces, were squeezed against their bodies and squeezed their arms. So despite being bent in one direction, they couldn't withstand the pressure of the body against the arm. The curved shape over here corresponds to the curvature of the rib cage, so it fits exactly on the lower rib cage, and it feels very comfortable when someone pushes you against it, or it feels comfortable also when you place it on over your metal cuirass. Here we should also make mention of the depth of the shield, the optimal depth of the shield. So it seems that the depth of the shield has not actually changed throughout the time, and although we can expect that there were always some variation in depth, there was also variation in diameter. This variation was not something that we can detect changing throughout the time, and there is a few reasons about that. One of them is related to the Porpax. First of all, the minimum shield depth is determined by the height of the Porpax. So when you let the shield on the ground, you leave the shield on the ground, the Porpax needs to be rested securely inside the dome of the shield. The shield cannot be narrower than that, otherwise every time that you put the shield on the ground, the Porpax will be squeezed or damaged. The other factor has to do with exactly what I mentioned previously. So the at rest placement of the shield is that when the ball touches my shoulder and the rim touches my thigh. And in this position, the curvature of the Porpax has to correspond with my body. It shouldn't be very far away from my body, otherwise when I'm pressed, my spine will have to bend so that eventually it will touch and rest on the Porpax. Or if the depth is very small, then every time that I rest my shield on my body, the Porpax will touch before the rim touches my thigh. So there is an optimal shield depth and Porpax height that has to work with the body. Another very important factor about the Porpax, one that has been well known since a long time, but we don't very often see it in reconstructions, is the Porpax placement on the shield. So we are certain that the Porpax was not supposed to be placed in the center of the shield. It was always, or almost always, placed off-center. Let me show you what I mean. The center of the shield is around here. The Porpax is placed higher and towards the front. We know that from archaeology. How? Because the shield bands, they have decorative squares, and on the top band we always find fewer of these decorative squares than the bottom one. We also know it because in a few full bronze face shields, the wooden core has disintegrated, and so the Porpax and shield fittings have been attached to the shield face, and so we know exactly where they were placed on the original shield. What determines the exact placement of the Porpax? It is body mechanics and ergonomics. So when I carry the shield, two things need to happen. One is that the shoulder of the shield needs to match my own shoulder, and my arm needs to be relatively close to the rim, so that I have more leverage in rotating the shield. Another thing is that as I rotate the shield, you will notice how the shoulder of the shield always corresponds with my shoulder. This makes the shield very comfortable to carry in long distances, and of course very comfortable to use in battle. In long marches, I'm sure that all reenactors have had to rest their forearm by bearing the whole weight of the shield from the Porpax, like this. And you can change the amount of weight that your forearm is bearing to the one that your hand is bearing by changing this angle. When the Porpax is placed on the center of the shield, it is very hard or impossible to achieve this ergonomics. Of course, this also works with the overall size, the diameter of the shield, and the size of the bearer's forearm and shoulder height. This particular shield is 95 centimeters in diameter, and my height is 1.75 meters. The average shield diameter may be close to 90 centimeters. I don't have the exact numbers about that, but there are shields that are well beyond that size. 95 is quite common, but there have been finds that exceed the 1 meter, 1.1 meter perhaps. And my height would have been on above average, so we have opted for an above average size for my shield. However, I think that modern reenactors should slightly size up their shield size because our modern average height is well above the ancient Greek height. Coming back to the shape of the Porpax and its functionality, there are a few more reasons why the ancient Greeks came up with this design and they stuck with it for centuries. One is the weight distribution. So suppose that we had a cone-shaped Porpax that fitted exactly the shape of the forearm. Then we would have a narrow ring that would fit the narrower spot, the narrower part of my arm, and the wider ring or rim that would fit the widest part. Then the weight of the shield would be distributed along the whole width of the Porpax only when the shield rested 90 degrees to the ground, parallel to the ground. Every time that the shield orientation changed, more of the weight would be distributed closer to the wider rim or the narrower rim. And I have felt that discomfort with my old shield, with a tubular Porpax, and I know how this shape that curves in all directions has accommodated that issue very effectively. Also, my arm is able to move in many directions while the shield is staying static if I want it to remain static, and the weight of the shield is distributed in a large part of the Porpax surface, whatever I do. So it feels very comfortable. In order for all this to work, there is a precondition, and this is that the Porpax has to fit very snugly on the forearm of the wearer. I have padded my Porpax with felt and leather so that it fitted my arm so tightly that you see that I raise the shield and I am carrying the whole weight of the shield only with my forearm, and none of the weight is borne from my upper arm. It sticks to the forearm, and that is also very comfortable. The snug fit of the Porpax on my forearm also ensures that I can move the shield without holding the antilabe. I can even rotate it sideways somewhat, only with the movement of my arm. Of course, the control becomes much better once I grab the antilabe, and now of course I have full control of the shield. The placement of the antilabe is very nuanced as well. The loops that hold the antilabe need to be on the shoulder of the shield and not on the flatter surface. And there are a couple of reasons. One is, of course, that the closer that my arm is on the attachment points are on the rim, I have better control over the rotation of the shield. But perhaps even more importantly, what it does is that it moves my knuckles away from the shield surface. So if you have sparred with hoplite shields where the Porpax was closer to the flat surface, you may have experienced an injuring of your knuckles, and I have definitely had very bad burns and bruises from sparring with a loose Porpax and the one placed closer to the center. The exact placement is the one where your knuckles barely touch or don't touch the surface at all, but the forearm is in its natural position. It's neither pulling your arm outwards nor letting your knuckles hit the shield surface. Also, it's very useful to have a very tight Porpax. You see that my arm barely reaches the my fingers barely reach the antilabe, and I have to pull tight in order to squeeze my arm in the Porpax and have very neat control of the shield like that. This shape of the fingers, the fact that the middle fingers close around the antilabe better than the index finger and the small finger is something that we see in ancient depictions, especially good quality statues, but also good quality vase paintings. To further demonstrate how the shape of the very curved Porpax accommodates various uses, I'm going to use this javelin, and you see that when I hold the javelin or the spear with my Porpax hand, my forearm needs to move sideways in the Porpax. However, the fit of the Porpax on my forearm is as comfortable as it used to be. And this is yet another reason that it needs to flex outwards both on the wider side and the narrower side. By squeezing the shaft against the rim, I can also have very good control of the shield, almost as good as by holding the antilabe. It's not as comfortable, but I can definitely stand it for quite some time. The usual way of holding the spear while on the march was this one. I can do it by holding the Porpax as well. And my spear shaft is very comfortable and secure between my neck and the shield ring. It can go nowhere. One last functionality of the anti-clastic shape of the Porpax was pointed out to me by Paul Barduñas, and this is that every time that you need to move your arm out of the Porpax, the hand and the palm has to hit the edges of the Porpax, and by moving the edges outward, you prevent injury, especially if we imagine that this had to happen in very violent conditions during battle. Another remark I would like to make about the placement of the antilabe is that it always needs to sit higher than the axis that passes horizontally through the center of the Porpax. I will try to hold the shield so that you can see it. Most people place their Porpax exactly, the antilabe exactly opposite the Porpax, whereas it needs to sit higher. And you can see that if I hold my forearm parallel to the ground, you see how when the top of my forearm is parallel, the bottom of my forearm is sloping out, upwards. This moves my grip higher than my forearm. If the antilabe was placed opposite the Porpax, then I would need to move my hand downwards in order to hold it, whereas now you can see how it is placed exactly at my hand and my fist. This is very important and makes the shield much more comfortable to bear and to use. Before wrapping this up, I would like to make a few more remarks that are connected to the size of the shield in relation to my body size and the placement of the Porpax, which moves the shield backwards and downwards. So one is that you can see how much of the shield is left behind me or to my side. There is almost room for one more person to be protected on my left. This could be either another hoplite that overlaps his shield to mine, but it could also be an archer or a peltast or a slinger or a stone thrower, like we hear about in Tyrtaeus' poems. Also, you see how the shield is covering almost my whole body. Again, as Tyrtaeus mentions, it covers me from head to knee, and if I bend, you see how the shield is actually covering my knee, and it's together with my greaves, which I'm not wearing right now, they work together to present a complete coverage of my body. With a smaller shield in relation to my body size, or a shield that is moved upwards due to a central placement of the Porpax, is not so able to provide. Another thing that an antilabe that is placed closer to the rim provides is more room to use my weapon, be it my spear or my sword. If I face a right-handed opponent, his blows are coming from my left toward the right, and a shield rim that is projecting further away from my body is not really providing that much more protection. If I am in a formation and I'm facing potential blows from my right, then I am supposed to seek coverage behind my comrade's shield to my right. So this was my analysis of what the Argive shield was, how it worked, how it evolved to be a very refined tool of war that dominated and defined the Greek battlefields for centuries.